think we have a phone call, so let's take that. Hello?
Hello.
Hi.
Hi.
Hi, thanks for calling. Do you have a question for us?
I do. I have a math problem here about polynomials, and
Okay.
they want to divide them.
Oh, okay.
That is an advanced algebra problem.
That's an advanced algebra problem. I could do this one. All right, so what's the question?
It is x squared plus 2x plus 1 divided by x plus 1.
X plus 1. Okay. I wrote that out. Let me ask you something. Are you watching?
I am.
Okay. Do you, there are two methods, long division and synthetic division. Does it matter to you which one you use? Like, are you familiar with one over the other, or does it matter?
No, it doesn't matter.
Okay. Personally, I prefer synthetic division just because long division is long, yeah, and it's kind of based on the idea or just hoping that everybody knows long division, and I think really at this point, not everybody does anymore. That's my opinion. So I tend to prefer synthetic division. So we'll go that route.
Okay.
What I'll explain, I guess, is the setup and what's happening, and it's really not any division, which is kind of cool. Which is why it's called synthetic division is because it's really faking it. It gets us the answer as if we divided. We just don't ever actually really have to divide, which is nice. So the way we set it up is in this box would be the root that you would be using. Essentially what you gave me with this x plus 1, this is a factor, meaning we're saying that x plus 1 probably goes into this. And then if that's a factor, the root is always this guy. So really, when you're thinking about the root in relation to the factor, it's just the opposite of the number that I'm highlighting right now.
Okay.
So we'd say it would be like -1. Does that make sense?
Yeah.
So that goes there. And then what we set up next to it are the coefficients of the polynomial that we're dividing. So coefficients are just really the numbers in front. I'm going to highlight them. So 1, 2, and 1. So basically we're taking the variables out of it so that they don't mess with the problem. So we'll say 1, 2, and 1. And then we draw a line. So that's the setup.
Okay.
Then from there, the process kind of goes like this. Is the first number will always bring down to the bottom. And then we're going to multiply, add, multiply, add. So what I mean is we'll take this 1 times the -1, and we get -1. And we'll put our answer below the next one. And then we add. So 2 plus -1, 1. We're going to multiply again, 1 times -1, -1, and add again, and we get 0. So again, it's bring down, whatever we get, we multiply by the root, we put our answer under the coefficient, add. Multiply, add, multiply, add until we're totally finished.
Okay.
So no division, actually. We're done with actual division. We just have to interpret our answer. The last number is always going to be your remainder. So thinking about division, if you get a remainder of 0, what does that mean?
There's nothing left?
Yeah, nothing left. It went into it evenly. We don't have to worry about a remainder or a decimal or anything like that. It goes into it evenly.
Okay.
And then what I'm highlighting now, give me 1 second, this actually here is our answer when we did the division. It looks weird, I know, but it's just like how we did the coefficients at the beginning. We just ignored our x's and the x squared. It's kind of the same idea here, is ignoring our x's. So this first here is our constant, just like this. And then this next one is the x term. If we had any more, it'd be the x squared. And then keep going x to the third, because you can do this with a lot of different polynomials. but we just go up to x. So essentially, our answer to this is 1x plus 1.
Okay.
And probably, I guess, the way that you would maybe write your answer is like this. And I'll get rid of here, and we would just say, when we divide it, it equals x plus 1. So thinking about that kind of backwards, if we were to take x plus 1 times x plus 1, we should get back to that polynomial that we started with, if that makes any sense.
Yeah.
Do you have any follow-up questions? I sound like Sam. Do you have any other questions or follow-up questions on what we did?
No, I think that explains it.
Good. Okay, good. Thank you. I feel like
Thank
there's
you.
just a lot of background knowledge to it, so I wasn't sure if I was filling you in on as much as I needed to or not. but
Yeah.
Thank you. Thanks for calling.
Yeah, of course. Thank you.
All right.
I bet there's a way you could even check your answer.
I bet I
How would
could.
you do that?
I really bet I could.
Nate is dying to check the answer.
Subscribe. Come on, push the button.
You know you want to.
Do it.